You ever stop and wonder how your computer, well, does anything? The secret is this invisible, super high-speed system called PCI Express, or PCIe. You can think of it as the digital nervous system that lets all the parts of your PC talk to each other. And today, we're going to pull back the curtain and see exactly how it works.
Okay, so picture this. You've just finished editing a massive video, you hit save, and boom, it's done. Almost instantly. What in the world just happened? How did all those gigabytes of data get from one place to another in the blink of an eye? That, my friends, is the incredibly clever system we're about to unpack.
So here's how we're going to break it all down. First, we'll start with a really simple way to think about it. Then we'll look at the language these components are speaking. After that, we'll dive into a crucial trade-off between getting things done fast versus getting them done right. We'll see it all play out in a real example. And finally, we'll talk about why this whole system is so important. Let's do it.
All right, Section 1, the computer's nervous system. Now, to really wrap our heads around this, we need a good analogy.
And honestly, the best way to think about PCIe is like an insanely efficient postal service running inside your computer. Your CPU, your graphics card, your SSD, they're all like different buildings in a city. And the data they're constantly zipping back and forth, well, that's the mail.
And in this postal system, every single piece of mail, every letter, and every package is called a transaction layer packet, or a TLP for short. It doesn't matter if it's a tiny little command or a huge chunk of a video file, it gets sealed up in one of these standard TLP envelopes before it goes anywhere.
So that brings us to Section 2, speaking in digital packets. Because, not all mail is the same, right? Let's look at the different kinds of TLPs flying around in there.
They basically fall into four main types. You've got your essentials, stuff going to and from memory, commands for your input-output devices, and all the configuration data to make sure everything's set up correctly. But PCIe also added this really cool fourth type, messages. These are for more high-level stuff like signaling an error or telling a component to power down.
Okay, but here's where things get really interesting. This digital postal service offers two completely different delivery options, posted and non-posted. And the choice between them, well, it's this fundamental balancing act between raw speed and guaranteed reliability. This is the absolute core of how PCIe works so well.
Let's dive into that. Section 3, confirmation versus speed. This is the crucial trade-off.
Just think of non-posted transactions as certified mail. You send your package, and you absolutely need a signed receipt back to prove it was delivered. That receipt is called a completion packet. It's a bit slower because you have to wait for it, but you know for a fact it got there. Posted transactions, that's your bulk mail. You just stuff the flyers in the mailbox and trust they'll arrive. No receipt, no confirmation, you just fire and forget. You're trading that guarantee for pure, unadulterated speed.
And this is just brilliant. Check this out. This table shows you exactly when each one is used. A memory read, for example, is non-posted, which makes total sense, right? If your CPU is asking for a piece of data, it needs to know it actually got it. But a memory write, that's posted. Your system just blasts the data over to the drive and moves on, prioritizing speed above all else. It's such an elegant and efficient design.
All right, Section 4, a transaction in action. Let's actually follow a couple of these digital letters and see how they make their journey.
First up, our certified letter, a non-posted read transaction. This is where we need that proof of delivery.
Okay, step 1. The requester, let's say it's your CPU, sends out a memory read request packet. It's addressed to the completer, we'll say that's your SSD. The letter is officially in the mail system.
Next, the SSD gets that packet. It basically cracks open the letter, reads the request, and says, aha, the CPU wants this specific bit of data. Then it goes and grabs it.
And here is the final, brilliant step. The SSD bundles up the data the CPU wanted into a new packet called a completion with data packet and sends it back. I mean, how smart is that? It's the receipt and the actual package, all in one. The transaction is complete, and the CPU knows it has what it asked for.
Now let's look at the complete opposite, our bulk flyer, the post-it write. This is all about speed, speed, speed.
And get this, it is so much simpler. The requester just packs the data into a memory write packet and sends it. And that's it. It's over. No waiting for a reply, no confirmation needed. It's a one-way trip. The system just trusts it got there and immediately moves on to the next task. That's why saving that giant file feels instantaneous.
So, we've seen the letters get sent and received.
But how do they know where to go in this digital city? Well, they travel through a network of switches. You can think of these like the central post offices or sorting hubs. They read the address on every single packet and route it down the right path to make sure it gets to the correct building.
Okay, so we've gone through the nitty-gritty. Section 5. Why does any of this actually matter? What's the big takeaway here?
It's this non-stop high-speed postal service, all running on these simple but incredibly elegant rules, is the invisible backbone of modern computing. It's what makes everything we take for granted possible, from games that load in a heartbeat to editing huge video files without a single stutter.
And it all comes back to that one brilliant trade-off, knowing exactly when to use the slow but reliable certified mail and when to use the lightning-fast bulk mail. That single decision, made millions of times a second, is how engineers squeeze every last ounce of performance out of the devices we all use every single day.
It really makes you think, though. As our data gets bigger, as AI and VR demand more and more bandwidth, what new rules is this digital postal service going to need? What new kinds of delivery will it have to invent to keep up with the future? Definitely something to chew on. Thanks for joining me on this one.